Is the audio now? Is everybody done? Okay, so what I'm gonna do is what do I do first? I probably need to rewrite it, right?
Yeah.
So it's gonna be 7x minus 1 to the 4 over 3, right?
Yeah.
And then now I'm gonna take a derivative of that. So if I take a derivative of that, I take it down to power. Because I'm gonna take it, I'm gonna kind of look at this. This is a first layer, and this is a second layer. That's a way to look at it. I call it, the kind of like bubble gum. So then it's going to be 4 over 3, 7x to the minus 1 to the 4 over 3, 2 over 4 over 3 minus 1 times by derivative of 7x, so it'll be 7. So it'll be 28 over 3 times 7x minus 1 to the 1/3. And that's it. That's a chain rule. Are we okay here? Asheville, you understand?
Yeah.
Okay. Jonathan?
Yeah.
Okay.
And you're writing it as 28 over 3 cube root 7x minus 1 over 2, right?
Yeah. You can do cube root, but just do 1/3 is fine.
Yeah.
Okay, so what happened is we're gonna look at this and we're gonna say, hey, can we combination of two rules? And this one's a little bit harder. So what if I have this y equal to 2x minus 1 to the 4th to the 5x minus 3 to the 3rd? Okay. Now, the derivative part is not hard. The simplified part of this one is hard. So make sure you follow my lead. Is the algebra part is the one that's going to get you more. So let's first of all, let's understand this. Which kind of rule is involved here? Connor?
The chain and product rule?
Chain and product rule. How many times the chain rule involved? Twice, right? And the product rule, the product rule only occurred once. So we're gonna take care of this. We're gonna call this as like maybe g of x, and this is maybe f of x. So what we're gonna do is we're gonna take a derivative accordingly. So if I take a derivative of this, then I'm gonna take a derivative of this part first. So it's gonna be 4 times 2x minus 1 to the 3rd. Does that make sense?
Yeah.
Now, am I missing something? What am I missing?
Times 2 from inside.
Times 2 for inside. Good. And then we are okay here. Now we're going to leave the first part, the second part alone here. So here it's going to be 5x minus 3 to the 3rd. Are we okay here? Plus, we're going to leave the first one alone to the 4th times derivative of the second part, which is 3 times 5x minus 3 to the 2nd. What am I missing? Am I missing some? 5, right? So usually people forget about this part, which is 5, this is 2. Usually forgot about those two numbers, which is derivative of the inside, and don't forget that. Now, how do I simplify this? So I'm going to show you how to simplify this, which is factor out the most negative exponents. So GCF, you look at GCF. What is GCF between those two things here?
5x minus 3.
5x minus 3. Okay, let's do that. 5x minus 3 to the which power?
D to the second.
Second power. Good. Because between 3 and 2, I'm going to take out the second. Are we okay here? And I'm going to take out 2x minus 1. Between 3 and 4, which one I'm taking out? 3. And I'm going to put a bracket. What happened in bracket? Well, 2x minus 1, if I take out 2x minus 1 to the third, that means this whole thing is out. And only left with 5x minus 3, so it'll be 5x minus 3 to the, sorry, that's not right. That's not right. It's 8 times 5x minus 3. Are we okay here? Because 4 times 2 is 8. Am I going too fast?
No.
Plus 3 and 5 is a 15 times, well, if I take out to the third and I take out the second, only 2x minus 1 left. So it's equal to 5x minus 3 to the square, 2x minus 1 to the third, times 40x minus 24 plus 30x minus 15. So that's equal to 70x minus 39.
Yes.
And then, so why do I need to do this though? Why? Is the derivative is already done here? Yeah, derivative is done. There's no need to do this. But when do I need to do this? Think about when. When do I need to simplify all the way? Yes.
You want to find zeros?
You want to find not zeros, but yeah, you find 0, but why do I need to find zeros?
Horizontal tangent?
Yes. So you need to find horizontal tangent. It has to go through here, right? If I say horizontal tangent, you have to simplify all the way. Because there was 3 horizontal tangent at 2 over 5, 1/2, and 39 over 70. But if I just says, if I want to find equation tangent line at x equal to 0, then just plug in 0 here, and then you move on. Because you don't want to waste time to simplify. So it really depends on when you want to simplify and when you don't want to simplify in this case. Not a lot of time you need to simplify. If I want to find equation tangent line at x equal to 0, guess what? I plug in 0 after I take a derivative. If I want to find horizontal tangent, then I will take a simplify all the way. So I'm going to give you a question that make sure you guys all know how to simplify. So let's say 5x, that's not 5x, let's say 3x minus 7 to the 8th power, and then 5 minus 2x to the 5th power. And I want to take a derivative of this. If I want to take a derivative of this, again, if I find equation tangent line just after you take a derivative, plug in a value. If I want to find horizontal tangent, you had to go all the way. If I ask you to simplify all the way, you had to simplify all the way. On the test, I'm going to ask you to simplify all the way just because I want you to be able to do both. But if you find the equation tangent line, don't spend time on doing the problem. Just spend the time just taking the derivative, plugging the value, and you're done. You move on further to the next problem. So you don't want to spend time on that. So I'll give you some time to work.